Okay, here we go. Example 4 for thermochemistry, Mrs. Peachy, Chem 2. How much heat is given off when 1 mole of liquid water cools 100 degrees to 10 degrees Celsius? First of all, we need to evaluate the equations we have, the algebraic equations. We have these three right here. And let's see. As I look up in this problem, I see a change in temperature, and the only formula that allows me to do a change in temperature is this one. We'll be using this one quite frequently. But when you get to a mastery quiz or a test, they're all going to be mixed up. So I'm just trying to model for you how you would think through how to use which formula. So we established, and again, please don't be tempted just to copy all this down. If you copy all this down, you won't have any clue what you're doing. So if you're going to copy it all down, great, pause the video, copy it all down, and then listen through the parts that I discuss with you so you understand how to do the problem. Keeping in mind we have decided that we're using this formula. Q equals M times C times delta T. Okay, just like before, I highly recommend it, almost insisted that you write down your units, or your variables, excuse me. So Q, M, C, and then of course for delta T we want to do TF minus TI. Then plug numbers in. So as I read the problem, I know I'm looking for Q, I look for my question word, how much heat, heat is Q. It tells me the mass, oh I don't see mass here, we'll talk about that in a moment. Does tell me that it's water, so I automatically know C. Keep in mind that if it's water, I don't expect that I have to give you C. I expect you to be able to get it from your blue card, 4.18 joules per gram degree Celsius. However, I do know that it cools from 100 degrees to 10 degrees, so my TF is 10 degrees, my TF is 10 degrees, and my TI is 100 degrees Celsius. Now, okay, we need to talk now about how I knew that the mass was 18.02 grams, because as you can see, nowhere in this problem do you see 18.02 grams. However, we know that we have 1 mole of water. Anytime I know I have a mole of something, and I know what that something is, I can convert it to grams by the molar mass. So we know 1 mole of water, and I'm using 0.000, so we sig figs. And then I could say for every 1 mole of water, I have 18.02 grams of water from the periodic table, so therefore I can convert a mole of water into grams of water. Likewise, I can convert any number of moles of water into grams of water using this conversion factor and switching out the value of moles. So that's how I got the 18.02 here. Alright, now that we've got our variables listed, we can plug them in. Q equals M times C times delta T. Plug in 18.02 for mass, plug in 4.18 joules grams degrees Celsius for C, and then delta T is going to be final 10.00 minus 100.00 degrees Celsius. So I get a negative when I multiply these numbers. If you need to, put this in your calculator in parentheses would be helpful, or do it first and then put it in your calculator. But if you would put this in here just like this, putting parentheses around that will save you the trouble of doing something incorrectly. When you do this math, you get a negative 6,780 joules with sig figs. Okay, going on to problem number 5. Example number 5. Okay, so we look at example 5, I read through it and I say, oh, which equation am I going to use? Because we don't know which equation if they're all mixed up. However, of course, we are working in this section of our unit, so we do know we're going to use this one. What would give me a clue that I did that? Well, needed that formula, that I need this formula. Well, because I see the word specific heat. And these two don't have specific heat in them, but the third one does. Okay, so, going on. So again, please refrain or stop yourself from just copying and not paying attention. I highly recommend that you copy it and then go back through and listen to the video again. So here we have titanium is a metal used in jet engines. Its specific heat is 0.523 joules per gram degree Celsius. If 5.88 grams of titanium absorbs, very important, 4.78 joules, what is the change in temperature? Okay, so we know which equation we're using. We talked about that already. We're going to list our variables here. So as I do that, I get 4.78 joules, which I get right out of here. Now, remember, anytime we write the word joules, we should figure out whether it's a positive or negative. It says absorb, so that unit is positive. All right. We know the mass of 5.88 grams, and we know specific heat, it's given to us, 0.523 joules per gram degree Celsius. Now, we need to know the change in temperature, so therefore I have neither TF or TI, because what I'm ultimately solving is not for TF or TI, but delta T. So, plug in the numbers, 4.78 joules for Q. Notice it doesn't have a sign. I really should probably go back here and make sure I add a plus, because we want to make sure that our brains have said, yes, we've considered whether it's plus or minus. Plug in the mass, 5.88 grams. Plug in the specific heat, 0.523 joules grams degree Celsius. and then delta T, because that's what we're solving for. So I'm going to multiply these two numbers and then divide them over. So 4.78 joules divided by 5.88 times 0.523. Put that all in your calculator, whichever way you want to, so that you can get the answer of 1.55 degrees Celsius.